Hi, my name is Joshua Duvall. I'll be presenting the second half of Team 13's instrument design presentation. And I'd like to start with slide number 7 of our presentation, featuring the electric Cigar 10 guitar. A few notable features of this particular instrument are its compact size, very easy to handle, hold, but not too small that it can't be played easily. A high level of playability, as the configuration is very similar to a standard guitar. Any musician who is familiar with playing a guitar can pick this up and pretty much just go right at it. This instrument also, it features 4 fully tunable strings which offer a fairly wide range of pitches and a lot of versatility there. Another option that we thought was a neat addition is actually a piezoelectric transducer pickup, allowing amplification, and that is output through a 1/4 inch audio jack and is also volume controllable via a potentiometer. So next we'll move to slide 8, and this is what we're going to talk about here are the underlying physics of this instrument, the electric guitar, the electric Cigar 10 guitar. The strings in this particular instrument are tuned matching the first through 4 strings on a standard guitar, providing frequency outputs of 329 Hz, which is the key of E4, 246 Hz, which is the key of B3, 196 Hz, which is G3, and 146 Hz, which is the key of D3. The string lengths in this instrument are 9 inches. We had to set them at 9 inches to stay within our criteria for string length. The desired frequencies are acquired via adjustable string tension as well as differing string diameters. The required string tension for each string diameter was calculated to provide consistent feel and feedback. Differing string diameters also enhance playability by providing variance in string feel, given a tangible reference to which string is being played without having to verify by sight. That's a neat feature in my opinion. There's a lot of musicians will often multitask, whether they're singing or maybe out in the crowd, having the ability to know they're on the right key without having to look it's a plus for sure. Audio amplification output is provided by means of a piezoelectric transducer, which we talked about a little bit earlier. The piezo, referred here to as a pickup, converts string vibration transferred into the body of the instrument into an AC signal, in essence. This signal is then output to the user's preferred amplification device, and that's done through the 1/4 inch audio jack connection. Volume control is obtained by impeding the signal with a variable resistor called a potentiometer, and that potentiometer will have a knob attached to it for easy access. By increasing the potentiometer's resistance value, the amplitude of the AC signal from the pickup decreases linearly as the potentiometer is turned, all the way to the point to which the resistance level is greater than the signal output, signal potential. Pretty much you have no sound output at that point, so it gives a little bit more versatility, a little more control over what you want this thing to sound like, how loud you want it to be, especially in different conditions. Just a little extra perk there. And we will go to slide 9, featuring materials for this particular instrument. They're fairly straightforward. We're going to start with the body section, which consists of a Cigar 10, 5 inches by 4.5 inches. We have a few sections of wood. The longest pieces are the neck and spine sections. which are about 9.5 inches long, about 1.5 inches wide, and then we have a couple of small sections which more or less keep the string in place and keep them off of the body of the guitar and the neck. Say in the bridge section, very, very small pieces. Of course, we have the piezoelectric transducer, the 1/4 inch audio jack, and the volume potentiometer with knob, and those are all tied together with a small section of 24 gauge electrical wire. To build our tuners, we used 1/4 inch, or we will use 1/4 inch eye bolts, 4 of them in all, with 8 nuts, and that'll give us the ability to tension those strings as we want to get the pitch that we desire out of it. To stay within the criteria for string length, we went with 4 9-inch strings, which puts us at 36 inches total. In this case, we limited ourselves to 36 inches in order to use this instrument for 2 instruments or for 2 parts. We will go to slide 10 now, and this features the equations and calculations for the strings that we used in this design, this particular instrument. In order to obtain the pitch of 329 Hertz for string 1, we had to use a diameter of 0.30 millimeters, tension at 1.82 Newton meters. For string 2, which is 246 Hertz, key of B3, we used a string diameter of 0.38 millimeters, tensioned at 1.59 Newton meters. String 3, 196 Hertz, which is the key of G3, we used 0.51 millimeter diameter string, tensioned at 1.79 Newton meters. And last but not least, string 4, to obtain a frequency of 146 Hertz, the key of D3, we had to use string diameter of 0.61 millimeters, tension at 1.44 Newton meters. And as far as the justifications, we'll go to slide 11 now. A couple of the more major areas of justification that we felt we should include are size and cost, both of which we were able to come well under the target. As far as size is concerned, with the xylophone design, we were right about 1 foot by 1 foot by 1 foot, which obviously meets the 2 by 2 by 2 foot criteria. With the electric cigar tin guitar, we were at 9.5 inches long by 5 inches wide and just under 1 inch thick, so obviously certainly well below the criteria there. As far as cost is concerned, our total materials cost for the 2 instruments comes up right at $21.91, which puts us about $8.09 below budget. Not bad, considering how dynamic these instruments are. Total cost for the electric cigar tin guitar is $9.78. Apologize, bringing us $5.22 below budget there. Total material cost for the xylophone is $12.13, bringing us about $2.80 below budget. At this point, I'd like to conclude the presentation, and I thank you for watching and hope to see you again soon.